the last topic, no, the next topic that we are going to learn is the way to find the solution for non-homogeneous differential equation. As I used to mention from the previous class that for non-homogeneous differential equation, we can write out it in the term of the general form of this type of differential equation as can be shown by this one, which is fx is a function of x over a constant, and fx shouldn't be equal to 0. So in that case, if this differential equation is defined as a non-homogeneous differential equation, then the answer of the solution of this differential equation is equal to yc plus yp. yc is the general solution which is coming from you setting this differential equation to be a homogeneous equation. Then your yc would be in the form of c1y1 plus c2y2 until cnyn. And the other solution is called yp. yp is the particular solution. So you can find yc by the previous lecture. So the next topic that we are going to go over is the method to find yp. So to find yp, we are going to learn 3 techniques. The first one is called the method of undetermined coefficients. The second one we call the operator method. So under the topic of operator method, we are going to learn 3 different techniques, which is called subtractive integration, partial fraction decomposition of operator, and the shortcut. And under the shortcut, we'll divide it into 5 cases, and then you will learn each cases how to find yp. And the third method that we are going to learn is about the method of variation of parameters. So these 3 methods are the way to find yp. So for non-homogeneous differential equation, your solution would combine with 2 different parts, yc and yp. Okay, yc you learned from the previous lecture already how to find yc. You got to set up the characteristic equation and find out the roots of the m, right? Whether it is in go to what case. We have 4 different cases to find yc. So you just figure it out what is your root m, and then the answer will go by case. And to find yp is the next topic that we are going to learn, and our yp is we can find by 3 methods. So you can pick either one. It just depends on fx. Okay. The first one that we are going to learn is the method of undetermined coefficients, and the second method is the operator method. The third one is called the method of variation of parameters. So let's go to the first one first, which is method of undetermined coefficients. With this method, if we have the differential equation as shown in this equation, this is the nth order of differential equation, and assume that a1, an minus 1 until a0 is a constant. Okay. If we assume that an minus 1, an minus 2 until a0 is a constant, and fx is a function of x or constant. Fine. Okay. They're saying that if you want to find yp by using the method of undetermined coefficients, you got to check your fx. Your fx got to be a single term of a special type, a special function. What are those functions? Those functions could be polynomial. So polynomial just go by x to the power k. Could be the exponential. A is a constant. This one k is also constant. And k got to be positive only. It's got to be the positive integer. Cannot be negative, cannot be minus. Okay. And got to be integer. Positive integer. A could be any constant number. Can be plus, minus, can be anything. Another function is sine or cosine. And the last one is the product of either function here. Function 1 and function 2, function 1 and function 3, function 2 and function 3, or function 1, 2, and 3. So if your fx fit in either 1, 2, 3, or 4, then you can use this kind of technique, this method, to find yp. So this is just remark. Keep in mind that the method of undetermined coefficient applies only to non-homogeneity that fx are in function 1, 2, 3, or 4. If not, for example, if you have tan x, tangent of x, is tangent of x fit in any one of these categories? Tangent of x. It's got to be product. Product it means ผลคูณของฟังก์ชันนะคะ tangent เนี่ยมันคือ sin over cos มันคือผลหาร so tangent x is not in this category. So if your fx is a tangent of x, you cannot use this method to find yp. How about ln x? Is ln x fitting in any of these categories? Ln x, logarithm of x. So if your fx is ln x, can you use this method to find yp? Can you use this method to find yp if fx is ln x? No, we can't, because ln x is not in 1, not in 2, not 3, and not 4. What if you have x times sin x? If your fx is x times sin x, can you use this method to find yp? Can you? Yes, you can, because it is fit in which categories? 1, 2, or 3, or 4? 4. Okay, in order to find yp by this method, first you got to find the successive derivative of your fx. The meanings of successive derivative of fx, that means you do differential of your fx. You do derivative of your fx until you get constant. The set of UC of your fx, you just pick up the function and the derivative of your function. You take only function. You don't take the constant, you don't take the sign or any number in front of that function. And then you write it down as a set. You call it set UC of function fx. UC comes from undetermined coefficient. So set of the undetermined coefficient of fx. This set comes from the successive derivative of that function x without sign and number. Okay, you take only the function. For example, I said that I have x to the power 4 if is the fx of your differential equation. Can we use the method of undetermined coefficients to find yp if fx is equal to x to the power 4? Can we use this method to find yp if our fx is x to the power 4? Can we? Yes, because x to the power 4 is fit with the first function. Now, we are going to find set UC of x to the power 4. The way that we do that is just that we do the first derivative of fx. The first derivative of x to the power 4 is 4x to the power 3. And the second derivative of it is 12x to the power 2. And the third derivative is 24 times x. And the fourth derivative is 24. How about the fifth one? If you do more derivatives to the fifth time, what do you get? 0. So it just stop there at the constant number. And then we said that if you want to write out the set UC of this function, you've got to take the function only, the function of that function and its derivative. So that means you would get x to the power 4. This one is, what is the function of this one? X to the power 3. This is x to the power 2. And this is x to the power 1. And this one is x to the power 0. X to the power 0 equal to 1. So I just write it down as a set of this function, which is composed of x to the power 4, x to the power 3, x to the power 2, x to the power 1, and 1, which is equal to x to the power 0. This one called set UC of function x to the power 4. I don't take the number or the size of the function. We take only function. Now, how about this? We have the function of cos 3x. If our fx here is equal to cos 3x, can we use this method to find yp for this differential equation? If this fx is equal to cos 3x, can we use the undetermined coefficients method to find yp? If this fx is equal to cos 3x, Yes, because it is fit with category 3. So, in order to use this method, you should be able to find ZUC of this function. So the question is that find ZUC of cos 3x. So the way that you do is just that you do the derivative of cos 3x. So the first derivative of cos 3x is 3 or minus 3. Minus 3 sine 3x. So what about the second derivative of this function? The first derivative you got minus 3 cos 3x. So the second derivative is the first derivative is minus 3 sine 3x. What about the second derivative is minus 9 cos 3x. So you find out that the function itself just starting to repeat. Then you don't need to do more differential, because then if you do derivative of cos, you will get sine, derivative of sine, you get cos. So then you don't need to do more, because it just started to repeat. So in that case, when you write down the ZUC of this function, you would get cos 3x and sine 3x. And that's it. Don't take the number and don't take the sign. The sign of it, like plus or minus, you just take the function. You see what is the function, then that would be the function. So the ZUC composed of function, that function, and its derivative. Now what if I have fx is x exponential of 3x? The exponential of 3x is also what? The function in our UC, right? The special type, which is in the category 2, right? So if you want to find the UC set of this function, you do derivative of exponential of 3x. The first derivative of exponential of 3x is the first derivative of exponential of 3x is 3 times exponential of 3x. If you do further derivative, you still getting the same function, which is exponential of 3x. So in that case, just stop right there. And then when you write down the set UC of exponential 3x, you would get only exponential of 3x.